Hi folks, my name is Prasad, and for this session, I'm going to demonstrate a multi-cluster monitoring with Couchbase Prometheus Exporter, which comes along with Couchbase Autonomous Operator. So the agenda for this is to have a quick overview of the metrics monitoring stack, followed by a demo. Let's go to the overview first. This is the metrics monitoring stack. It looks kind of busy, so let me break it down for you. So on the left-hand side of the screen, in these three blue boxes, you can see that there are three Couchbase nodes. This is part of a single cluster, and it has been deployed using the Couchbase Autonomous Operator. Now, since I've chosen to actually deploy the Prometheus Exporter along with the Couchbase cluster itself, you can see in this yellow oval over here, there's a CV metrics exporter, which is a Couchbase metrics exporter. Now, in a given pod, which is outlined in blue, there are two containers, one running a Couchbase node and the other running the Couchbase metrics Prometheus exporter. And this second container, we call it as a sidecar. Now, to be sure, what I'm showing is a single cluster, but it's the same argument even if you deploy multiple clusters. Now let's come to the rest of the components which you see on the screen over here. For this, once I've deployed the cluster along with Prometheus Exporter, you can actually start ingesting all these metrics on your own Prometheus server using your own installed Grafana. That is fine. But for the purposes of this demonstration, I'll be using a cool open source project called Cube Prometheus. What this does is that it is going to deploy, just like the Couchbase Autonomous Operator, it's going to deploy a Prometheus server, which is highly available, a Grafana server, an alert manager. It's going to deploy a couple of services, a Couchbase service, which actually looks and monitors all the Couchbase clusters, and a service discovery, which targets all the Couchbase services which have been deployed. So now that we have the metrics monitoring stack and the general architecture of it, let us start by actually starting to deploy some of these over here. So for this, I've created a nice kind of a cheat sheet to help me in remembering all these commands. So the first one is, let's go through the cheat sheet and see what we are going to do over here. First, of course, we are actually going to download the Couchbase Autonomous Operator version 202. Then we are going to create an EKS cluster. Now, this actually takes about 15 to 20 minutes. And to save time, I have already done this. Once this is done, we can actually install the Couchbase Autonomous Operator CRD, which is a custom resource definitions, and install the autonomous operator itself. We'll check the status of the operator. Then we'll deploy a couple of Couchbase clusters. Verify the deployment, examine a Couchbase pod. Once that is done, we can access the Couchbase admin UI. We generate some workload later on. But before that, we'll be installing the Cube Prometheus. The Cube Prometheus, like I said, is going to install and Prometheus server, a Grafana server, alert manager, and it's going to do a couple more things. It's going to deploy some service and a service monitor. And if you look at the picture, this Prometheus CRD is supplied by the Cube Prometheus, it will actually match or target the Couchbase service monitor, and the Couchbase service monitor will discover all the Couchbase service over here. And when I'm actually doing it, you will get to understand this better. Once we do this deploy Cube Prometheus, we'll check out the monitoring namespaces, check out that all the services have been created, etc. Once that is done, we will forward all the ports which we are interested in from the pods which have been deployed on the cloud, so that I can access all these UIs from my Chrome browser on my laptop. Once that is done, I'll check out the Prometheus targets, the raw Couchbase metrics, check out Grafana, and build a dashboard and look at the live metrics as they're coming through, which will end the demo. So now let us open a terminal and start executing these commands which are there in the cheat sheet. Okay, so I've opened a terminal over here, and in my downloaded Couchbase Autonomous Operator files, I'm in the directory of the Autonomous Operator itself, taking a quick look at all the files which are there. Some of those files I've created myself by modifying what has been supplied. Okay, but first, let us take a quick look at what the services which have already been deployed, and they should not be many. So if you say kubectl get svc, as you see, there are no services at all because we haven't actually deployed any. But let us take a look at the pods for all the namespaces over here. You can see, but there are already some pods, and all these pods are in the namespace cube system, and these are the ones which come along with the EKS cluster itself. So now that we have those, now it's time to actually start creating our CRD files, which is the custom resource definition, which comes along with the operator over here. So for that, I have to actually execute this, of course. So I'll copy this and execute this. It's created all the custom resource definitions. Once I have created the custom resource definitions, I have to install the operator itself, and the operator gets installed. It's pretty fast. Now, let me see if we can get all the deployments. So now, yes, we have the Couchbase operator, and it also installed the DAC, which is the Couchbase of admissions controller. It's still not ready yet. Refreshing once again, we see that both of them are ready. Now, let us look at get pods, all namespaces. Now you can see that apart from the cube system pods, we also have two pods, like we said, but they are in the default namespace because I've chosen not to create any of these in any named namespace, if you will. Now that we have this, let us start by actually deploying a cluster. But first, let us look at one of these YAML files, and let's go through that. So this is what we're going to deploy. And here in this YAML file, you can see the first section starts with a secret. And the name is the CB cluster auth. And this is the admin password. And this is what we will be using when accessing the Couchbase UI. The second one is, it's a Couchbase bucket. And we are going to choose to manage the buckets ourselves instead of having the autonomous operator manage the buckets for us. The third section over here is actually going to deploy the cluster. I mentioned the cluster name, the image, which is the Couchbase server 6.5.1. You can use 6.6, no problem in that. CB cluster auth. So this is the admin secret, which I've already created as the first section over here. Buckets, I put false over here because I want to manage my own buckets over here. Then I'm going to deploy these 4 services for this particular demo. But finally, I'm going to also deploy the Prometheus Exporter, and the version of the exporter is 1.0.2. So now that we have seen the anatomy of this YAML file, let's go ahead and deploy this. And for this, all we have to do is simply say create. And as you can see, it has created the secret, and it has created that bucket, which is going to be self-managed, not operator managed. And it is also deployed a pod, the actual cluster, sorry, not the pod. To get the pods, we'll have to do kubectl get pods. Remember, I'm doing this in the default namespace, so I really don't have to put in the namespace. By default, it's going to get all the pods belonging to the default namespace. As you can see, one of those nodes is coming up. Remember, we had mentioned it's going to be a 3-node cluster here. The servers, the size is 3, and it's going to have these services on 3 nodes. So I expect to see 3 nodes over here. The first node is ready. Let me refresh this once again. Okay, now the other 2 nodes have come up, but they're still not running. So let us wait for a few seconds. Get the pods once again. The first one is up and ready. It's going to take just a few seconds more for the rest to come up, and we'll keep doing it pretty fast. Okay, less than a minute. All of them are ready. So we have got 1 cluster now deployed. Let us examine, let us describe one of the pods. Describe a pod. Let me take the first one and see what it has. When I describe this, so let me go into this. What does it contain? So the name of that pod itself, the IP, the app. It has the app called Couchbase. Now this is important because this label is the label which we are going to use in the Prometheus Couchbase service file, and it is going to look at this app, and this is the connecting piece between the Couchbase service and the Couchbase cluster itself. So it has got all these services which have been enabled. So you can see that I've got the Couchbase pod, which is 1 container, and this node has 1 container, which is a Couchbase server. But remember, we also chose to deploy the exporter. So we have another container, which is the Couchbase exporter, and both of them are up and running. So far so good. We have done 1. Let us do the other one. So for the other one, I'll go back, create. But before creating the cluster 2, let me quickly examine what this cluster 2 YAML file is. So if I cat this file, I can see that it doesn't contain the first 2 sections. The first 2 sections were the secret and the bucket. And that is common to the cluster. For the namespace, it is common to the namespace. So every cluster which you create in the namespace will get the same secret, will get the same bucket action. So I don't have to recreate them once more. But so this becomes a much simpler version. All I have to do is simply say, oh, the kind is a Couchbase cluster. The name is Couchbase cluster 2. I chose to use the same 6.5.1, the same services, the same size, which is 3 nodes, and I also have monitoring and the same version of the Prometheus exporter on it. Now that I have that, let me go ahead and actually create this cluster 2. So here it simply says this cluster 2 created. But now, as you know, you have to see what the pods are. If you look at the pods, we still don't have any, right? Because it takes a minute, as we have seen. And so let us refresh this and see what's happening over here. Once we refresh this, you see the cluster 2 coming up. Okay, the first one, the first cluster is already up and running. The second cluster is just starting to come up. The first pod has been created. We know that it has 3 pods, so we have to refresh this a couple of times and wait for about 30 seconds. And in 30 seconds, we'll have this all up and running. So let's refresh this once more. It's still up and running. So let me pause for about 10 seconds or 20 seconds and come back. Back, as you have seen, I've refreshed it a couple of times more, and now I can see that both my clusters are up and running, the operator is up and running. So the next part in the cheat sheet is actually go and look and start deploying Cube Prometheus. So for this, let me go over here to another window in the terminal. I have downloaded the Cube Prometheus project. Let me examine what's there. These are the files. These are the files which have been supplied along with it, and the deployment is exactly the same as you. Again, there's a YAML file, and you create all the CRDs and all the spots. But specifically for Couchbase, we have to do 2 additional files. So let me see what those files are. And they are in the manifest directory over here, and I've actually created them. And those 2 files are called Couchbase Service YAML and Couchbase Service Monitor YAML. Let me look at the first one, which is the Couchbase Service. Okay, so the Couchbase Service itself simply says, okay, the name of this is Couchbase Metrics, but this is important. See the app, the labels. The same label was there in the Couchbase cluster. And this is how this service knows that it is going to tie itself with the apps which have the label of Couchbase. That is, every Couchbase cluster will have this, right? And this is important, right? And the port, we have named it metrics, it can be anything, but the port itself is, the port number is 9091. And this is the port in which the metrics, Couchbase metrics, are exposed and are ingested from. If I wanted, I could have actually specified the Couchbase cluster, but here, as you can see, I have commented it out. So let me take a look at the next file. So this is the Couchbase service. This service is actually going to run in the default namespace. Now the other one is called the Couchbase Monitor, Service Monitor. And all this has is, we have called it a service, the kind is called the Service Monitor. And as usual, the app, how does it know how to discover or target all the Couchbase services? By the app name. Here, I don't have to mention that port 9091. All it knows is the app name, and it will target towards the app name so that the Prometheus server can then ingest all the different Couchbase clusters from port 9091 and get all the metrics into the server itself. Right. Now that we have this, let us start deploying this. So for the first one, it's a 2-step process. First, we'll have to create all the manifests, and this will take just a few seconds. Now, all the manifest setup has been done. Now, this will be done in just a few seconds. So let us go to the next step and actually finish and create the rest of the resources. Now, here is the main one, and here you can see that there's a lot of resources which are being created. Basically, we are creating Grafana, we are creating Prometheus, we are creating the alert manager, and we are creating various role bindings, service accounts in the namespace. The interesting thing is, Prometheus, we are going to create all of this in a namespace called monitoring. Why couldn't I have done it in the default namespace? It's just best practice. So I'll stick to the best practices to get all this. So just to make sure that we have all the pods, just like we checked in Couchbase, let us check the pods. And we're going to look at the namespace of monitoring. And these are the pods which have been created by Prometheus. I can as well say get pods for all namespaces. Here it lists only the namespace monitoring. Here you can see default, I have two Couchbase clusters, cube systems. This is the Kubernetes itself. Then we have this monitoring namespace, and these are all the different pods. I can examine the ready status for every one of them, and all of them are ready and up and running. So now we have done deployed Prometheus also. So all that is left now is to forward some of this ports which we are interested in. And to do that, let me look at this file, which is over here. Sorry for this. Cat. I put it in a small shelf script over here so that I don't have to type out the individual commands. But I just want to go walk through this. What I'm specifying over here is, in the Couchbase cluster itself, every pod is running in the cloud in EKS. And I'm going to forward the port of 8091, which is the default Couchbase admin UI, and onto the local port of 9000, which means I can open my Chrome browser at 9000. I'll be looking at cluster 1. 9001, I'll be looking at cluster 2. 9090, I'll be looking at Prometheus. 3000 port, I'll be looking at Grafana. 9091 Couchbase metrics, I'll be looking at the raw metrics. So now that I have this file, let me actually forward this. Okay, now that I've run the script, you can see that it's forwarding all the ports, it's handling all the connections. We have this up and running. So we are done for the present with the terminal portion of this. So let me start sharing my Chrome browser and continue the demo from the browser. Okay, so now I have my Chrome browser up, and like I said previously from the port forwarding, I'm going to look at 9000. 9000 is going to be my cluster 1, and 9001 is going to be my cluster 2. So now, if I look at cluster 1, I've actually logged into this UI using administration user ID and password as password, the exact same thing which I'd actually specified as my secret when deploying the Kubernetes Autonomous Operator. So now that I have it, I can see the 3 nodes. They're all healthy, but it still doesn't have any buckets. So let me create. In cluster 1, I'm going to create the sample bucket. Okay, go back to buckets. Travel sample is getting created. I'm going to add one more bucket over here, and I'm going to name it pillow. Why? Because I want to run the pillow fight on this. I'm going to add this bucket. So this cluster is going to have 2 buckets. One is travel sample, one is pillow. So let me do the same thing for the other one. But in this one, I choose to have beer sample. Got sample data. Go back to buckets, same as usual, add bucket, 1 cluster 200, same with the same name. Why? Because I just want to show how it's going to look in Grafana. So let's see where we are. Server 1, we have this pillow, no documents yet. Travel sample is complete. Server 2, we have this pillow, empty, beer sample, complete. So we are done with the UI portion of this. We'll come back to this later. So as you remember, I had exposed 3 more ports. One is for the metrics, one is for the actual Prometheus itself, and one is for Grafana. Let me start with metrics. So if I look at metrics and if you see over there, since we already have Prometheus Exporter exporting data right now, we still haven't gotten the Grafana. These are all the raw metrics. So as you can see, we are already getting some metrics over here. I mean, all the metrics over here actually. But this is kind of very busy, kind of complicated, but it's useful because this actually helps you to get what the labels are and what is the command which you should use. And it also has a little bit of help information on to describe what this actual metric does. Okay, now that we have it, let us go to the Prometheus time series. And over here, you can see that I have, so right now, it's going to take a few minutes for no current items. This is again on the port 9090. And I'm using a language called PromQL, which is Prometheus SQL. And actually, once I do this and execute this, it'll actually show me, it'll actually fetch the metrics associated with the CB bucket per node. Okay. Once I have this, now let me examine this and let us walk through this. What does it show? This metric shows that it is fetching all the current items or the number of documents. And it says it's collecting them per node. So I have 3 nodes. And as you know, the beer sample has around 7,000. So about 2,400 odd per node. Why per node? When I want to look at the total number of documents in the cluster, because I choose to do the aggregation in Grafana rather than over here, which is best practice. Same thing with travel sample. I have 10,000 per node, 21,000 in all. I have both the clusters, cluster 1 and cluster 2, which is seen over here. And the service is called Couchbase metrics, and there is a label for this. And it also shows me the pod name, it shows me the bucket name, and it shows me the instance type, etc. The main thing for us is that we are interested in this cluster name because in Grafana, we want to sort it out by cluster. We are interested in this pod name, where in Grafana, we choose to call it a node instead of a pod. We are interested in the bucket, and we are interested in the service because this is what our query is going to point to. And when I go into Grafana, I'll explain a little bit more in detail about how we are going to use this. So now that we have this, we have seen this. Let me actually go to Grafana, which is actually in 3000. First time I'm starting Grafana, so admin, which is the default. It'll ask me to change the password. Let me do that. There's no dashboard, sure enough. So it has created a data source for us that is part of the Q Prometheus, and it is now asking us to build a dashboard, right? I can build it step by step, and it takes, because I want to avoid a little bit of typing, what I'm going to do is I'm going to import a dashboard which I already have. And then describe how I have created this dashboard. So right now, never mind this, let us go immediately into the dashboard settings. And this is where you would start with a new dashboard. So I've named this dashboard as Couchbase Operations. And I'm going to create 3 variables which I can drop down in the Grafana dashboard. So right now I'm going to do cluster. So let me begin with cluster. So I've named it cluster, and this is a query, and the query I say is service equals Couchbase metrics. Why? This is what we saw in the PromQL. Couchbase service equals Couchbase metrics. So I have it in this dashboard. Now this cluster is a regex expression, and what it is going to do is the PromQL, it is going to get all the things associated with Couchbase metrics, this whole list, but it is going to do a regex and get that cluster name from this. So the cluster, the service, this is what is the cluster name, right? And the cool thing is, once you do this, it'll show you a preview. So I have 2 clusters, it's showing me both the clusters, right? Let me go to the next variable, node, same deal. I have this Prometheus as the data source and this query. Service is still Couchbase metrics, but here I've added one more condition. What I'm saying is, when displaying my node, make sure that you display everything only for one cluster. If I have 6 nodes in my Grafana dashboard, I don't want to drop down all 6 nodes. I just want to drop down and look at the nodes which are associated with this particular cluster. Okay, again, this regex is in pod. Why pod? Because going back to this, it says over here, it says pod, right? Now, same deal with the preview. You can see that there's a Couchbase cluster, there are 3 nodes, and it's showing all 3 nodes. And here selection option, there's a multi-value, there's an include all operation, which I've chosen to enable. Going back, let us finish off with the last one, which is bucket. So in bucket, the same deal. The name is bucket, and the query now is again service, Couchbase metrics, cluster, depending on this cluster. But again, now add one more saying, hey, when I am looking at bucket metrics, give me for that cluster, for that particular pod, and for the bucket, right? And that bucket regex expression is still over here, and the rest of the stuff is still the same, right? So we have this pillow and we have this travel sample, which is shown in this preview. So now that I have the variables, I can go back to Couchbase operations and actually look at the dashboard. Before actually going into the dashboard itself, let me edit I have a couple of panels over here. Let me edit one of these panels and show you how I build the panel. So for building the panel, I first need to have the query. The target is Prometheus for sure. So the metrics has got to be the metrics, the actual, it's going to be a sum, and it is got by the CP per node bucket current items. Where did I get this from? Again, going back to time series, this is what it is, current items from here. And what I'm saying over here is, get it from all this, where bucket equals bucket, which is pulled down from here, the variable, where the pod equals node. Why node? Because I've named this as node over here instead of pod, just to avoid some kind of confusion between what is a pod and what is a server node. That's all. And sorted by bucket. So these are the metrics. Okay. And in the next step, and look, the aggregation is done over here. For the next step is, how do I visualize it? This again is what is the label, and I can show the right-hand side label, and I can show the legend. I can show these values. What is the minimum? What is the maximum? What is the current? Which it will automatically display over here. So this is the first panel. Now let me look at how I constructed the second panel. Kind of exactly the same deal. Here, I'm interested in getting not just one single line graph, but 3. I want to get the bucket operations, I want to get the get operations, and I want the set operations, and I want the total operations, right? As usual, I'm going to do the summation. I'm going to use cv command get, right? So Originally, we had over here current items, but I can replace this with command get over here and execute, and I'll get all this. So right now, there is nothing to get. I mean, everything in the value is 0 because there are no operations being performed, right? But the same, because I have 3 now, I have 3 queries. One is command get, one is command set, one is total ops. The rest of it is the same as before. I can create a legend, etc. And I can name this panel. I can have a min-max if I want to show, right? Now that I have created a Couchbase, a Grafana dashboard, along with this 2 panels, there are so many metrics which you can choose, but for the purpose of demo, let me just choose 2 panels. Now I have this. Now I know this pillow travel. So I have all this get operations and set operations. You remember that in cluster 1, we had travel, sample, and pillow. Let me drag down cluster 2, and it becomes beer, sample, and pillow, right? So now that we have this, let us make this graph a little bit more interesting by actually performing some operations. And for this, I'll have to get back to my terminal. So let me stop this view and share the terminal view from here. Back to the terminal view and back inside the Couchbase Autonomous Operator files. We have supplied a pillow file data loader.yaml. So this is kind of a little bit of a misnomer because it's just not a data loader, but it actually performs operations on it. And I've just, we are taking a look at this file, what it contains. It is a job, and the name is, we call it pillow fight. And this is actually a utility which comes along with the Couchbase server itself. It's called CBC pillow fight. And here, we can get all this different options. The cluster, the pod itself, I've got this over here. How did I get this? You can actually see it from the UI or when describing the pod. The bucket name is pillow because I just created a bucket called pillow. So now that I have this, all I have to do is now go to cube control, create -f pillow fight data loader. Now it has created a job. Okay, now that it has created a job, now let us switch back to Chrome and see what's happening over there. Okay, back to Chrome, but first I'm choosing to look at the cluster 1 UI just to make sure. Okay, I've got pillow, originally it had 0, now it has 10,000 items, and look, it is doing some operations. 35,000, sometimes it'll go up to 40,000. Just to make sure, I'm going to go to cluster 2. Since in cluster 2, I don't have the job running, this pillow bucket over here doesn't have any operations at all. Now that I have this, let us see the exact same things on the Grafana, but before that, as you know, you can look at statistics right from here. And when I click on this, now you can see the total number of ops per second, and I can see the number of gets over here. I can see the number of sets over here, and I can actually pull it down and look at it per node. Here I can pull down and look at the other thing also, but here I'm choosing to use pillow because I'm not doing any operations of travel sample. But look at these graphs. Now let us look at how these look in Grafana. Coming back to this Grafana screen, here you can see last 5 minutes. Cluster 2, the buckets are over here. I can see the number of operations over here. And if I have to refresh this momentarily, no operations. Why? I'm pointing to cluster 2. So let me pull down cluster 1 where I actually have the operations, and here now we can see the operations coming through. And it's pretty much the same as what we had in the Couchbase UI. I can see the gets, I can see the sets, and I can see the total number of operations over here. But here I see it for both travel sample. So just to make sure, I'm interested in pillow alone, not in travel sample. Let me click on that. Now I have only for a pillow because travel sample has no operations on it. And here you can see the total number of operations. For example, it says 38K. The total ops, around 42 has been the maximum. But if I can choose to show only one single node instead of all, and do not aggregate, and you can see now per node the number of operations over here. Okay, so now we have a truly multi-cluster monitoring system, 2 clusters, multiple nodes, multiple buckets, some with the same name. Here, of course, I could have chosen to display this as a pillow and the name of the cluster 2, but just for simplicity's sake, I just annotated them as below the bucket name itself and nothing more than that. So this is the complete demo of a multi-cluster operating system. So let me stop sharing my Chrome and go back to my presentation. So that was the end of the demo. I hope you enjoyed it. I hope it was useful for you. And I hope you actually try out our Couchbase Autonomous Operator and deploy your own Prometheus Exporter with your Prometheus and Grafana dashboards. Here's my contact information. Thank you very much. I really appreciate the time you have spent with me. And if you have any questions, I'll answer them right now. Thank you.